We are looking at conics, specifically the general form of a conic, and trying to decide what shape it is so that we can graph it. Step one is look at which terms are being squared, x squared and y squared. So we put x squared and y squared. You look at the relationship between the two. Are they x squared minus y squared minus x squared, or addition? Then you look at, in the general form of a conic, ax squared plus bxy plus cy squared, et cetera, compare these two coefficients. If they're the same and it's a plus between them, it's going to be a circle. If they're different, a equals c, no, then it's going to be an ellipse. So if they're both squared with a positive and different, it's an ellipse. If they're both squared with a positive and they're the same, then it's a circle. If they're both squared and it's a negative, then this doesn't matter. It'll be a hyperbola. And if there's only one of these squared, this is what we'll talk about next class, is parabolas. Now, as you identified, this is an ellipse. Therefore, we're going to change it into standard form by completing the square. So the first part of that is I'm going to take all of my x terms and group them together. And then I'm going to take my y terms and group them together. So I'm going to leave a little space after this, plus 49y squared plus 196y. And then I'm going to move that 4 over so it's to the left, to the right side, -4. What's my first step here? I need a 1. I need a lead coefficient of 1. So I'm going to factor that 4 out. X squared minus 2x blank. And I'll do the same here. Factor out the lead coefficient. Y squared plus 4y plus blank is -4. And now I'm going to turn this into a perfect square. I know that if this is an x squared in front, I need an x there. I also know that whatever term this is, when it's squared, it gives me this. And when the product of these two is doubled, it gives me this. So therefore, half of this minus 1 would be my term here. In other words, as a perfect square, this would be x minus 1 squared, which gives me x squared minus 2x plus what? This thing squared plus 1. Now, I've just tilted my equation. I've added stuff to the left side of the equation that I didn't add to the right, so I've changed the value of this equation. To keep it balanced, I have to add that same amount to the other side. Since this is inside the parentheses, it's all being multiplied by 4. So I didn't really add 1. How much did I really add to this side of the equation? Yeah, so I'm going to have to add 4 on this side to keep it balanced. Now, let's do the same with a y. I've got a 49 out here. And inside here, if this is y squared, this has to be y. What's the term that goes here? Good. Half of this means plus 2. When I square it, it puts a positive 4 up there to make this a perfect square. But because there's a lead coefficient of 49, I didn't really add positive 4. I added 4 times 49, or 196. And so when I clean this up, positive 4, -4 cancel. I'm left with a 196 here. And I'm almost there. But the hyperbola and the ellipse both have a 1 here instead of a 196. So what do I need to divide this whole thing by? 196. When I do this, most times it works out nicely like this. You'll find that the 4 goes into 196. 196 is actually 49 times 4. And so when I divide this 4 out of this, I end up with x minus 1 squared over 49, a nice perfect square. Plus the 49 divides out, leaving a 4 on the bottom. So there's my equation. Any questions on getting to that part? 5, I can complete the square like that. 3, I watched you do it. I'm not facile with it yet. I'm going to have to practice, but I get the idea. 1, this is confusing to me. Okay, hands down. From this, once it's in this form, what's our center? 1, -2. What's our A value? Square root of 49 is 7. What's our B value? Square root of 4 is 2. Do you remember how we get our C, our focus? Really close. Come back over to the other side here. If we're dealing with an ellipse, C squared is equal to A squared minus B squared. Or B squared minus A squared, whichever one's bigger. And then if we're dealing with a hyperbola, that's what we just suggested. C squared equals A squared plus B squared. Kind of confusing because the ellipse has a plus between the x squared and the y squared, and this one's minus. Whereas the hyperbola has a minus between the x squared and the y squared, and it's plus. All right, so in this case, we're going to take A squared minus B squared, so C is equal to root 45, which becomes 3 root 5. And what I'd like to ask over here is, again, I'm sorry that my whiteout wasn't working here. I crossed out the word discriminant here. Would you please write foci? And we're going to put the actual focus points right there. Let's start by graphing this whole thing. What's the center? Yes. Thanks. Center we said was 1, -2. So 1, -2. A is the part under the x. So when I take that 7, I'm going to go left and right in the x direction. 1, 2, 3, 4, 5, 6, 7. That's called a vertex. And the other way, 1, 2, 3, 4, 5, 6, 7. Also a vertex. It's called a vertex in the ellipse because it's part of the major axis, the longer one. The one that's under the B, excuse me, the Y is a B. And in this case, the square root of 4 is 2. And so that's the one that goes up and down. And because it's not as big as the 7, it's not called the major axis, it's called the minor axis. And instead of these being vertices, they're now called, good, co-vertices. And so if I just connect these vertices and co-vertices, I produce a very short ellipse. And I've got just 2 more points to graph. What are those points? Yes, the foci. And what we know is that the foci is C units over from this center along the major axis. So since this one's going left and right for the major axis, it's longer than it is tall. We're going to go C units left and C units right. C is the square root of 45, which is approximately what value? Like between what whole numbers? Between 6 and 7, right? Square root of 49 would be 7. Square root of 36 is 6. So it's 6.5-ish. So we're going to go over 1, 2, 3, 4, 5, 6.5. The foci are way out here. And for our plotting of points, it's going to be very rough. But what I want you to do over here is give me the exact values. So we're going to start with a value of positive 1x, -2, and then we're going left and right, 3 root 5. So it's 1 plus or minus 3 root 5, comma, -2. Those are our 2 foci. Like what it means or how to find it? So, yeah, let's say that I've got a scenario that's like this, okay? It's a wide one where this is the major axis versus this one, where now this is the major axis. See the difference? Okay. They're both going to have a center in the center. And let's say for both of these scenarios, we've got, like in this case, we'll say that A is equal to let's go with, let's see, 20. Let's say that that's equal to 5 and b is equal to 3. Okay. So in this case, I would say c squared is equal to a squared minus b squared. So c squared is equal to 25 minus 9, which is 16. So c is equal to 4. That tells me that my focus is 4 units away from the center. And because this is the major axis, if my center here were, I don't know, 2, -7, my focal point here would be affecting the x. Instead of it being just 2, I'm going to say 2 plus 4, comma, -7. And going in this direction, I'd take 2 minus 4, comma, -7. So the actual point would end up being -2, -7 here, and 6, -7. Whereas down here, if I had the exact same values, but now the one under the x is the 9 and the one under the y is the 25, so it's going this way, my c would still be 4. But now I'd say if this point were 2, comma, -7 again, but now I have to affect the y value with my c. So I'd be adding 4 or subtracting 4 from this. Yeah. 2, -7 plus 4, and 2, -7 minus 4. So it'd be 2, -3, and 2, -11. Is that kind of what you're asking? Yeah, but with radicals, of course, it looks different. Okay, yeah.
Like how we know if it's a circle, an ellipse, or a hyperbola based on the square, like the plus or minus.
Yeah. If it's a circle, then what you're going to see is x minus h squared plus y minus k squared equals r squared. That's a circle. And so the components that we care about are, there's a plus there, and the lead coefficients are the same. If it's an ellipse, what we'd see is something similar to this, but we might see something like 9x minus h squared plus 16y minus k squared. And the number over here would end up being something like 144, so that when I divide it by 144, because there was a lead coefficient here, 9 goes into 144 16 times. 16 goes into 144 9 times. And now this is equal to 1. So in an ellipse, we expect still a plus, but we expect that the denominator here and the denominator here are different. And the indicator that leads towards that is if up here we had seen that these coefficients had been the same, then when we divide by the r squared, they'll end up the same. So if they need to end up different, these coefficients have to be different. Question, Ari? Yeah. Then the third one is when it's x minus h squared over a squared minus y minus k squared over b squared equals 1, where it's a subtraction sign between them. This would be a hyperbola. And of course, it could be the other way as well. It could be y minus k squared over a squared minus x minus h squared over b squared equals 1. Also a hyperbola. The difference is which direction it is. If it's got an x first, it ends up looking like that. If it's got a y first, it ends up looking like that. Okay, and again, this is being recorded, so you guys will have this on video. All right, let's do another one. Take a look at this one. What's being squared? Well, because we're trying to find out how to distinguish it. Y squared only. Okay, do we care about the plus or minus? We really don't. It's a minus, but it doesn't really matter. A equals C, not applicable, because when it's just 1, that's what it is. We're going to talk about parabolas next class. So you don't know how to do this right now, but we can still complete the square. Y squared, let's put it with the y, minus 6y, leave a space, and move everything else over to the right side. 4x plus 19. Now we're going to complete this square. So what would this have to have been if it were a perfect square? Good, y minus 3. And when I FOIL that out, I get y squared, minus 3y, minus another 3y is minus 6y. What goes here? Plus 9. And if I do that to one side, I got to add it to the other side. So plus 9 over here equals 4x plus 28. What we'll learn, and you'll get this next class, is that the standard form of a parabola for this shape, we would factor out that x, the 4 coefficient of x, and this would be the way we'd write it. That's different than the way we've done parabolas in the past, isn't it? So we're going to have a day on that. Leave that for now. Don't graph the parabola. Okay, let's take a look at number 3. What's being squared? X squared, y squared. Plus or minus? Minus. Are A and C the same? No, can't be. Type of shape? Hyperbola. It's not the worst shape. So it's not hyperbole, right? Any chuckles from English people? No? Okay. You guys know what hyperbole means? Okay. All right, what do I do first? We're going to complete the square. Good. So let's group the x's together. So 9x squared plus 72x blank minus y squared minus 4y blank equals negative 131. Let's get rid of our lead coefficient. So I'm going to divide a 9 out of this one. X squared plus 8x. I'm going to take a negative 1 out of this one. So I get y squared plus 4y blank equals negative 131. So this one's going to end up being 9 times what squared? Good, x plus 4. And when I put that in, I'm going to get x squared plus 4x plus another 4x makes 8x. What goes here in the back? Plus 16. But I didn't really add 16. I added 16 times 9. So over here, I'm going to add a 144, which is 16 times 9. Minus 1 times what? Plus 2, right? Because I factored out a negative 1. So it's a plus 4 in there. So I'm going to go plus 2. When I FOIL that out, I'm going to get a plus 4 up here. But how much did I really add to that side? Negative 4. So I got to put a negative 4 up here, which means negative 135 plus 144 is a positive 9. So I've completed the squares, but to turn it into a hyperbola form, I need to get this right-hand constant to be 1. So what do I divide both sides by? Yep, divide this by 9, divide this by 9, divide this by 9. And these end up canceling. So now I get x plus 4 squared over 1 minus y plus 2 squared over 9 equals 1. So what's my center? Negative 4, negative 2. What's my A? Square root of 1, which is 1. What's my B? Yep, square root of 9, which is 3. And this is where my C squared is equal to A squared plus B squared. So this would be root 10. Now, yeah.
Same process. It's just this one has a negative.
Good question. And yes, the completing the square, the putting it into the standard form is exactly the same process, except that when you pull out your lead coefficient, it'll be negative. Good. And in fact, the process of then finding the center is identical. The process of finding the A and B is identical. The process of finding C is different. And the process of graphing it is different. So now let's graph it. I still graph the center. So I'm going to go 1, 2, 3, 4, 1, 2. There's my center point. And I still use my A to go left and right. So I'm going to put dots there. And then I'm going to put my B 3 up, 1, 2, 3, and 3 down, 1, 2, 3. Now, if this were an ellipse, I would draw it like this, right? I'd make a circle through those points. That's not the thing for a hyperbola. For a hyperbola, I make a box. It's a really tight box in this case. And then what I'm going to do is I'm going to draw asymptotes through these corners of the box. And whereas with an ellipse, I can tell which one's longer as the major axis, it's different here. This one, I'm looking for which one is the positive one in front. This is x squared in front minus y squared. So that tells me that my shape is going to be an X looking thing. Because the X is in front, it looks like this. So from this vertex, I'm going to run out along the asymptotes here. And from this vertex, I'm going to run out along the asymptotes here. So even though these vertices are taller this way, they're not on the major axis. The major axis for an X squared in front means it looks like this. The axis runs this way. So the focal points will be somewhere along this major axis. They're going to be out here, so that like if we're collecting rays from space, they're focusing in here in the middle of this cup. And so what we expect to see is that it's going to be the center point, which has an X value of -4, and it's moving left and right by this square root of 10. So our foci are going to be -4 plus or minus root 10, comma, -2. Those are our foci. How do you feel? 5. I feel competent completing the square, determining what shape it is, graphing it if it's an ellipse, a hyperbola, or circle. 3, I got a couple pieces to fill in the gaps, but generally I'm okay. 1, I'm less than generally okay. Okay, I'm going to close this up and just give you guys some time to work, and I'll circulate around. Finish this packet up as day 86.